Welcome to the Implementing Access Controls and Access Control Policy lecture. Access control is a method and means to implement the principle of least privilege and enforce CIA. It's used for both protection and detection. Access control impacts security, productivity, and the organization's ability to perform its mission. An access control policy sets the rules that define the conditions under which access may take place. An access control model connects the policies to the mechanisms. Verifying the conformance of policies and models is a critical task. A system's privacy and security are more often compromised by misconfiguration of access control than cryptographic failures. Access control policies are influenced by business requirements, the tolerance for risk, and regulatory requirements. Policies are dynamic in nature and will likely change over a system's life cycle. We'll speak about that as well today. For a system to be deemed trustworthy and secure, there must be sufficient confidence that the system is capable of enforcing the security policy on a continuous basis for the duration of the time that the policy is in effect. An access control list is a mechanism to implement access control for a system resource by enumerating the identities, that is, the persons or entities that are permitted to access the resource. An access control request can come from a human, can come from a human, a machine, a process, or an application. Access control rights are described as permissions or privileges. Linux file and directory permissions are defined as read, write, execute. Permissions in the Windows operating system depend on the type of object, but some common permissions are read, modify, change owner, and delete. Objects can be files, folders, printers, registry keys, and Active Directory domain service objects. Google Documents use a share feature to grant permission levels of viewer, commenter, or editor to an individual or group. Operating systems have access permissions for system administration, also known as system administrator or a root user. These privileged users are authorized to perform security-related functions that are not authorized to ordinary users, such as the ability to access, analyze, and synthesize data. Access control models can be based on the sensitivity levels of documents, the clearance level of users, the roles or group memberships of users, or they can be at the discretion of the owner of the object. The access control models typically use these concepts. Object is an entity that contains or receives information. Objects are records, fields in a database, pages, segments, files, directories, directory trees, processes, processors, video displays, keyboards, printers, network nodes, all sorts of things. Devices such as electrical switches, disk drives, relays, and mechanical components connected to a computer system, they might be objects as well. The next concept is a subject. An Active Directory is a subject, a person, process, or devices that cause information to flow among objects, or change the system state are subjects. Next concept is a permission or privilege, which is an authorization to perform some action on the system. An operation is an active process invoked by a subject. There are three models plus a hybrid that we're going to talk about today. The first is role-based access control, which is often referred to as RBAC. Second one is mandatory access control, or MAC. And the third is discretionary access control, referred to as DAC. Plus, again, the option of a hybrid combining elements of multiple modes. The role-based access controller, RBAC, involves the assignment of roles to users and permissions, privileges to roles. This approach is essential because assigning permissions directly to individuals becomes impractical even in a moderately sized organization. The role permissions reflect the permissions needed to perform defined functions within an organization. RBAC permissions are based on job roles, allowing employees to have access to the information required to fulfill work responsibilities. It is well suited to a distributed system that can enforce administrator-specified rules. Group policies can simplify management of permissions of users with similar access needs. The use of a group policy is scalable as well. Roles and groups can be updated without updating the privileges for every user individually. RBAC requires constant maintenance due to changes. Okay, so there are some challenges with it. Like I said, requires constant maintenance due to changes in job responsibility or the dynamic nature of an organization. RBAC requires continual updating of organizational charts, job definitions, data needs. Time pressure and business needs may result in workarounds in the RBAC that introduce security risks. The next model is the Mandatory Access Control Model, or MAC. This model restricts access to objects based on both the security level of the user and the sensitivity level, security attributes, of the object. MAC means that access control policy decisions are made by a central policy, not by the individual owner of an object or even a privileged user on the system. MAC requires labeling mechanisms and means to determine access based on policy. The access control mechanism must be able to compare the user's security attributes to those of the resource upon which they are trying to access. This is typically done with an access control list, which we mentioned earlier. ACLs is not Austin city limits. It's the access control list. ACLs are platform dependent, which adds to the overhead of managing subjects and objects. Users cannot change access rights. An example of MAC occurs in military security, where an individual data owner does not decide who has top secret clearance, nor can the owner change the classification of an object from top secret to secret classification. More commonly, cloud-based systems use MAC to prevent users, regardless of their privilege level, from modifying policies that could compromise security, such as enabling write access to a website directory. The next model is the discretionary access control model, or the DAC. The DAC leaves a certain amount of access control to the owner of an object or anyone else who is authorized to control the object's access. The owner can determine who gets access rights and what those rights should be. So DAC is generally used to limit a user's access to a file. It is the owner of the file who controls other users' access to that file. Only those users specified by the owner may have some combination of read, write, execute, whatever, permissions to the file. DAC is simple, it's flexible, it's widely used in business and in government. Access control lists and group membership are the most common mechanisms for implementing DAC policies. It does have some weaknesses, however. The weaknesses of DAC are that information can be copied from one object to another. There are no restrictions on the usage of information once it has been shared and privileges are decided by the owner of the object rather than through a system policy. DAC policy is vulnerable to Trojan horse attacks because programs inherit the identity of the invoking user. For example, a user writes a program that is presumably useful, but actually can delete files. The program is shared with the owner of a file, and it appears that the owner deleted their own files. The next model is more of a hybrid model that might add content or parts of the other models that we've discussed. So hybrid models primarily seek to add flexibility to access control. Role-based access control, RBAC, can be combined with attribute-based access control, ABAC. This approach combines a user's role with additional attributes to make access decisions. An attribute-based model uses characteristics of users, resources, and the environment. For example, the department, time of day, location, classification, or project name can be used to make context-aware decisions for access. The advantages of a hybrid model could be enhanced security. By combining different access control models, a hybrid approach can provide more granular and context-aware permissions, minimizing the risk of unauthorized access. Improved flexibility could be another advantage. It adapts to changing business needs by dynamically adjusting access controls based on user attributes and situational factors. Access control does have benefits and limitations. So first, the benefits. An access control model significantly reduces the attack surface by limiting privileges. This is important. In the case of account compromise, damage is limited to the privileges held by the account. So very important. Access control contributes to compliance with security standards and regulations. It also enhances data security in terms of confidentiality, integrity, and availability. Now, some of the limitations of access control could be implementation errors, such as privilege leakage, privilege blocking, inheritance, privilege conflict. There could be safety issues in which permissions have leaked to an unauthorized user. Separation of duties is a practice to mitigate issues of safety. Hierarchy vulnerabilities resulting from permissive inheritance in RBAC, implicit trust issues, or insufficient revocation of permissions. Another limitation is access control is dynamic in nature, and that is likely to change over time in reflection of ever-evolving business factors or government regulations or environmental conditions. Finally, system and data change constantly. Users change constantly. Threats change constantly. Are you seeing a theme here? Vulnerabilities change constantly. Therefore, cybersecurity is considered real time, meaning it requires constant monitoring. This necessitates the access control be revisited across the SDLC. So let's talk a little bit more about the dynamic nature of access control, right? So we've talked about access control changing over time due to evolving business factors. Important to remember, new government regulations or perhaps changing environmental conditions. Again, there's a dynamic nature. Security is real time, right? It requires constant monitoring. So this is contributing to the dynamic nature of the access control. Users change constantly, right? Threats and vulnerabilities, they all change. We mentioned that it's important that it integrates with the system development lifecycle, the SDLC. Access control must be revisited across all SDLC phases. The initiation phase, we should define access control requirements. The development phase, we need to design access control mechanisms. The implementation phase, we need to configure and test our controls. In the operations phase, we do need to monitor and maintain permissions. Remember, they're dynamic. And the disposal phase, we want to ensure decommissioning of access, right? Not just get a sledgehammer out. So we also need to make sure that regular review happens. It ensures that controls remain effective. Some of our key takeaways in this lecture are one, that access control is fundamental to implementing the least privilege and CIA. It's important that we know that the principle of least privilege, is access control is fundamental to that. Different models, the RBAC, MAC, DAC hybrid, serve different needs. Implementation must balance security, usability, and maintenance. Access control is dynamic and requires continuous monitoring, and access control must be integrated throughout the system development lifecycle. Now, there's a couple of exercises to complete now that we're done. Hopefully, they will help you understand access control better.